In covalent bonds, atoms share electrons, but sometimes atoms get greedy. Covalent bonds happen because atoms want to have complete or empty electron shells. To accomplish this, an atom can either gain electrons or lose them. Hydrogen gaining an electron would make a complete electron shell, and hydrogen losing an electron would make an empty electron shell. Sometimes an atom is closer to shedding its partial shell than completing it, and sometimes an atom is closer to completing its partial shell than shedding it. Sodium, for example, just needs to lose one electron to get an empty shell, so it really wants to get rid of it. But of course, if the electron left, it would make the atom positive and attract the electron again, so sodium can't just get rid of its electron. Chlorine has the opposite problem. It is one electron away from completing its shell. Even if another electron was around, attracting it would make the atom negative and repel it again. But if sodium and chlorine came together to form a molecule, the electron would gladly head to the chlorine. This makes chlorine negative and sodium positive. Because they aren't sharing an electron, the force that keeps them together is their electric charge. This kind of bond is called an ionic bond because the charged atoms are called ions. A less extreme version of this is polar molecules. This happens when one atom wants an electron a bit more than the other atom. Not enough to completely take the electron in an ionic bond, but enough to have the electron tend to stay around the atom more than the other. This makes one atom slightly positive and the other slightly negative. This makes it act like a tiny magnet. An example of a polar molecule is water. Oxygen is 2 electrons away from a complete shell, and hydrogen can go either way. This is in fact why life on Earth uses water. The polar nature of water lets it dissolve other molecules, which makes it very useful in cellular chemistry. Electronegativity is the measure of how much an atom wants electrons. Atoms with higher electronegativity end up being more negative in molecules. Atoms with lower electronegativity end up being more positive in molecules. Overall, covalent bonds aren't always the equal sharing of electrons.